Okay, today's problem is 496, next great element 1. Let me quickly, so it's from Leetcode. Let me quickly read this problem statement and I'll start solving it. Okay, let's try to run my understanding on a couple of examples they provided. So we have like two arrays, nums1, nums2, nums1 is a subset of nums2. We see that there are numbers like 4 is available here, 1 is available here, and 2 is available like here. And for the 4, we can find the next greater element. No, there is no greater element than 4 to the right of this array of nums2 array. Can you find the next greater element for 1? Yes, it's available, so it's like 3. And can you find the next greater element for 2? No, it's not available. And the same is here. For the 1, it's next greater element for 2 gonna be 3. Next greater element for 4, nothing, because it's the end of the array. So the size of this array is 1000. So doing the brute force, even doing the brute force, so like for every element we can run to the right, and for every element here we're gonna first try to find it and then run to the right and check who is the greater element for it. Like, let's say we have this input and output. Say when I input, yeah. So the first idea that I have in mind is a brute force algorithm where we for I from equals indexes, let's just do for num1 from nums1, we do for loop, and we try to find we do another for loop for num2, and then we do like first if, let's say, int of index, it's gonna be the first initial is gonna be -1, and if of index equals -1, then we wanna check if num1 equals num2, and then if so, we will update f index equals f index is equal, let's say whatever index, num2 index, and here else, so it means that we already found the first occurrence of the num1 in nums2. Then we need to check if num2 is greater than the num1, and if so, we need to write the output num1 index equals num2 index, and here like do the break out of this num2 loop, otherwise output num2 index, num1 index equals -1. So if we went through the all num2s and we haven't found num2 greater than num1, then it means it should be on the right to the num1 in num2, and we control for this with f index. If we don't find it there, we put it like we put the output we record on the num1 index, we record in the output array -1. We put -1 there. So that's it. The first idea, this was the first idea, and now I wanna try to improve it a little bit. Time complexity for this one. So the time complexity is O of time. It's gonna be O of n squared, and here like n is like 10 to the power of 3 or 4. Let me find it. 3, 10 to the power of 3 by 10 to the power of 3, and this equals 10 to the power of 6. So more or less okay for this case. Space complexity is of 1. Didn't use any space here, like it's constant, just a couple of variables, interim variables, and the output array, but we don't count it. So let me think about better approaches. For this problem. We are 10 minutes into the interview, so let me think if I can come up with some fancy idea how we can account for this. So the first idea that comes to my mind is that we always can save this array. It's kind of, so we need to somehow move forward and figure out if there is a greater element than then the current one. How it can do that doing just one traversal? One traversal. So if you go, if you have a stack, some kind of stack, so and we put the element there, if there, like we put on top of it, like say initially we put one. Let me make it clear. So we put one on top. Okay, then the next element is 2. We always put on top when the current element of the stack is higher than the one that we have now. So we have like 2 currently pointing, a pointer currently pointing to 2, and we do the following. We think about, okay, 2 is greater than 1. It means we need to pop out 1, and basically write down in our hash map 1, then 2, and then the stack now becomes like 2. Okay, we move pointer, we now have pointer pointing to 3, so we write down 2 is, we pop the value from the stack, write down 2 is equal to 3, and we add, so we push to the stack p, and we do 3, we push to the, so we move to the pointer to the 4, we popped the element 3 because the current element like a 4 is greater than 3, so we popped it 4, and then we now stack is equal to 4, and then in the end we pop all the elements from the stack and put like -1 there. 4 -1. So this example was a little bit easy. I'm looking into the better example that will have like something like this. Yeah. So it was increasing elements in nums2. So let me do this one. So this is gonna be second method. So we have nums2. Initially we have pointer pointing to 1. So we have like, let's say 1, 3, 4, 2. We have pointer pointing to 1. Then we have stack. So stack it has nothing on top of it. When stack has nothing on top of it, it just push into the stack. So we get and we move the pointer. So now pointer is like pointing on 3. 3 is greater than 1, that's the current element on the stack. So we go, we write the hash map output. We pop the element from a stack and we put 1 and record the current 3. We pop it and it becomes like 3 and push the 3. Then we move our pointer to 4. We check what's the current element on the stack. Current element is 3. 4 is greater than 3. So we again pop the element from the stack and write down add the record to hash map, and we push element to the stack. Okay. So next one is we have a pointer pointing to 2. 2 is less than 4. In this case, we just push the element in a stack. So the stack becomes 2, 4. And in the end, we go through all elements. We ran out of elements in nums2, and we just go through all elements and we add elements to the hash map. We pop elements from the stack and we add -1 to that one. And then we go through all elements in num1. And we basically try to retrieve the value nums1. We go to the hash map and we query the output. We query the key. With the key should be equal to the element from num1, and we write down the value in the output. So the time complexity. So it's, I guess this method is called monotonic stack. Monostack. And the time complexity of this is gonna be because we're gonna go through every element in nums2. Let's assume nums1 and nums2. So let's say nums2 is all of length is m, nums1 length is n. I assumed there that they are equal here, so I said, okay, the time complexity here going to be O of n squared, but actually if let's say n2 is the length len of nums2 and n1 is the length of num1. So the time complexity in this case is going to be O of n squared plus O of n2 squared plus O of n1. Because we need to finally go to the time complexity, so the time, so this one is, let's say, and here like the estimate is 10 to the 8 upper bound, and space complexity is again O of 1. So here like n2 n2 squared, like if the n1 is and n2 is of the same magnitude. Like squared time complexity, constant space complexity. And here in this example, in the monostack, we have time complexity, or to the of n2, because we just run through the nums2 array, and that's all, and we build the monostack. And in a stack, there is decreasing sequence, and in this case you're gonna always push to the stack. Let's say we have increasing sequence, we're also gonna push pop from the stack, and let's say we have like increasing and then decreasing sequence. So we have like decreasing and then increasing sequence. In this case you're gonna push to the stack and 2 over 2 elements, and then on every like next step here on increase, we're gonna pop just one element. That's gonna be like this. Time complexity of n2 plus of n1, and the space complexity in this case of n2, because we go through the nums2 array and we create monotonic stack and we create a hash map, and of n1 we go through the every element from nums1 array and we query it in our hash map, and we write down the output result. So the space complexity of this method gonna be O of n2, because in the worst case scenario we will have to add all elements in the monotonic stack. It will be decreasing sequence. And in this case, if the sequence is decreasing, we always keep pushing to the head of the to the head of the stack, and in the end we're gonna just pop all elements and put like -1, -1, -1, because obviously there is like for every level in this decreasing sequence there is no follow-up greater value that's located to the right of the element. So let me try coding. I guess the first one is not that. So there is a certain trade-off. We either can have like time complexity, great, but space complexity, so like time and space of n, or we can have time n squared and space like constant. Can we like, so we either have like time, space. For the first one we have like n squared. We have here we have like, and here like we have like we have this is O of n squared, this is O of 1, and then let's say we have here O of n have here, let's say O of n, and then we have here O of n. So we can have this is the solution of the just brute force BF, and this is solution of monostack, and we have we can have either like better space complexity, but still but worse uh, worse time complexity, or we can have better time complexity but increase in space complexity. Generally, I wanna like push the solution here to the like better space and time complexity, but it seems like there is a certain trade-off here between space and time. So let me try Leetcode the second approach. With 25 minutes into the interview, so yeah, probably will be fail, but let me code this on to show you how I can possibly solve this with monostack. So we have code here, we have this solution, say allow, there we have stack integer, and let's say we have for num for int I equals 1, 0, I less than nums 2 lengths, I'll say 2 equals and 2 equals nums 2 length and I'm gonna go while and we're gonna have this hash map of integer hash map and new hash. Let's say we have like stack and we have map hash map and we have here import the hash map and stack. Let's say we do while our stack peak, while stack peak is so we want to have decreasing sequence, yeah, is then the current element nums 2 I, I'm gonna stack pop into the value, and then we're gonna have if map get value not equal null, we're gonna if it equal null, we're gonna do what? No, if it's like stack peak, Okay, if the stack peak, so it was in the past, whatever you have in the past is okay, so it's okay, while it's greater than nums2, then we're gonna get this if map get value equals null. We're gonna put the map put value and then nums2I, and then in the end we're gonna stack pop push and then nums2I, and then while stack is empty, while stack is not empty, we're gonna just pop the element map push stack pop, and then here -1, and then for int I equals 0 I less than. So we can like save a little bit space here and there. Equals less than num1 length I plus plus, and we're gonna have this int output equals new nums2 length, here nums1 length, and the output we need to write down output equals hash map, our map get, and then okay, and then return output. So this should be it. This is monotonic stack solution. Let me quickly trace it. We have this example. This one is more interesting, and we should have this -3 3 and -1 3 and -1 output. Let me quickly trace it. So this one we have nums1 4 1 2. So we go through nums2 array and we track the hash map. So we have nums2 num2 equals 1 current. We have hash map just empty, and we have stack also. In the end we have stack, we put the, because it's empty, we go stack peak, I'll stack that is empty well, stack is not empty, and so it's here is empty. We push num1 instantly to the stack. So the second num2 equals 3. We check stack is not currently empty, so it has 1. Stack peak is less than 3, though it means that we pop element, we pop it, and so there we have 1, val equals 1, we try to get the 1 for the from the map. It's null, and we put hash hash map equals we put 1 and we put 3 there. Okay, and we also push now the stack is empty. We pushed one, we popped it, value 1, and then we push into the stack value 3. So we go next, num2 equals 4. We do the similar stuff. So in this case, value is we pop element from the stack because it's not empty. The stack element was 3. We put the we try to get 3 out of map. We cannot do that because there is no a key with the value of key. There is no key equals to 3 in the hash map, in our map. So we put this value and into the map, and the as a key equals 3, and the value for that entry is going to be 4. And then we emptied our stack and we pushed the 4 into the stack, and then we have num2 equals, next one is equals to 2, then the value current value in the stack we check if the peak, so if the 4 is less than 2, it's not true, so we don't do nothing there, and we just add value 2 in the head of the stack. We push it to the stack, and in this case we pushed it, and we move the I pointer. We ran out of the numbers in nums2 array, and we for every, and hash map in this was like this one, and for every element in now in the nums2 we just push the minus 1. We add here or put we put into the map, we put first, we pop 2 out of the stack, we put -1, and then let's do that separately. So we have stack and map state like this on this stage, yeah, like this on this stage, and like on this stage, So we pop elements from the stack, and we put -1 for that element in the map. So we have 4 -1, and the stack is that. So we kind of popped value 2, and we put -1 there, and then we popped value 4, and then put the -1 for 4 in our map, and then we go through those nums1 elements, and we put the output whatever we have there. So nums1 is 4, 1, 2, so the output equals 4, we query 4 in the map, so we put -1. For 3 we query 3 in the map as a key, we put 4, and for the -1 for the 2. If you query 2 in a map, you put -1. And the output is matches whatever output. Oh, we were querying 3. No, we were querying 1 actually here. 1 should be 3. Yep, that's it. Seems like working. Let me write down public static void test1, and then we have this nums arrays. Then then okay, let's try to do this. Test one. I don't know, maybe it's not working. Let's try to paste it in our Leetcode. Oh. Okay, few typos. Okay. Time. So I can definitely improve that. Let's check. I can definitely improve it with integer. Let's say int stack, new integer. How many elements we have here? We have 10 to the power of 4 elements. Okay. And we can have also the mapping Oh no, we have actually 10 to 1000 elements, and the values. So this is gonna be our map. Map equals new int, like this, and we don't need the stack or whatever hash map there, and we do further int as pointer equals 0 equals, let's say, -1, while stack pointer as pointer not equals -1, and stack SPTR. Let's make it shorter. We do just SPTR minus, and we put if you can probably just, because they are all distinct, we can just put well, int well equals stack and then we put well equals yeah, let's say we have integer map equals value equals nums2, right? And here we do stack push. So when we do stack push, we do as pointer. So we do plus as pointer. It's not convenient. We do as pointer, and then we do stack, and then we do value. Oh, nums2. And then we don't need this anymore. And while SPTR not equal -1, we do put. So we do we need to do that? I think we don't need to do that. And if we cannot get the value, so map nums I equals null, and if so -1, else it's gonna be just this. Yep, something like that. Let's run it. Oh, okay. Make it Okay, that's a little bit better. I wonder what on this range, on side of the range, and what's on this side of the range. So probably on this side of the range, I don't know, probably something that's better with the runtime. Something that's better with the runtime, other than this one, don't have anything in my mind. Let's check. So stack. Oh, they just limited that with this one. Okay. How do they? Why they have like integer here instead of like object integer? How they can escape that one? So the next grade top numbers 2 dot yeah, I guess there is some magic with head, and when we run out of it, no, there's no this kind of magic. But how this? Why there is instead of zeros that's initially initialized next greater with why there are gonna be the why instead of zeros are gonna be -1 in this stack for the one that's missing next greater elements. Okay, let's do this improvement first in our code. Still not beating. So the stack, while the stack top is not equal 1. Okay, so there kind of top, we always put a -1 head, that's why we don't check the pointer. Top, okay, and top, top minus minus, we move the pointer, next greater element for the nums 2. Ah, okay, I got it. So they do next greater element. So they rely on the again on these distinct values, and they always gonna yeah, that's I guess more beautiful solution of mine. It has less sharp edges and we don't need to check like for the length and for the null, and we don't need integer objects here. Yeah, okay. Let's check the memory. What's the best here? Okay, constant memory, so like n squared solution, brute force. Find, we have even find. For the find, yeah, it's even worse than that. So we have n cube, what? N cube. So here n squared, there find has like n cube, n of n, and we call find in this inner double for loop. So it's like n cube time complexity, and space complexity is like we just update the nums1. We don't even like allocate the output array. We just update it in place and it returns like even. Well, that's interesting. But in cube, yeah, again, if let's think, try to run this one. Runtime is still good. Yeah, Leetcode, you are you're making me sad. So in cube and it's still like not that. This one. I wonder why that's so slow. So you have stack, blah blah blah. For every element in the array, it's nums2, okay. For every element in the array, while not empty. Okay. What's this S? Okay, it's push. What? And we do in the end this double n squares? Huh. So basically we tried to do the monotonic stack here. Try to like do all n, and then we like screw it. Let's do n squared. Nums1 equals. So if nums1 equals nums2, then new array yacht. What? Why? Okay. Okay. So he basically tries to use all the pairs, like, and do these combinations of pairs, and he checks if they match, then output the result. If they're like, yeah, if they match. Yeah, but you can solve it with just a hash map or like an integer. Yeah. Probably this person, he doesn't know like this trick with hash map or array. To do that or like constant search. Okay, what are Yep, I'm gonna wrap up. So from the one point I tried to solve it with Monotonic Stack, and it was without any kind of logical errors. The solution was without errors. There were some like syntax errors, but it's fine. But I wasn't able to solve it within like 20 minutes. I guess it was like 30 minutes kind of when I like finished implementing Monotonic Stack. So I guess it's failed.